In this example, we will show you how to do threading or tasking. Since Netburner's toolset has a built-in real-time OS, we could take advantage of this. We will create 3 tasks with variables in each that it will be incrementing at different time rates. Let us get started. Let's create our new project by going to File, New, Project, Netburner Project. Let's name this Threading. Enter in your development kit. You can manually enter in your IP or do a search if it's already plugged in on your LAN. Click Next. We don't need a web server for this example, but it's out of habit that I click it. At this point, I like the file structure a little different. Let's create 2 new folders, one called Source and one called Headers. You don't have to do this. This is a habit I've picked up over the years, just to keep things a little bit more organized for myself. Let's drag the main application to the source folder. We now have errors, so we need to clean the project. So go to Project, Clean, click OK. Now it compiles. I'll do a little house cleaning here. At this point in time, we need to take all these includes here and bring them into the header file. So let's do that. Let's create a new header file. Name it headers.h. And let's go to our main application, and we're going to copy all those includes and paste them into the header file. And hit Control C, Control V. And we're going to save this. I'm going to hit Control S. Now we need to tell in our main application where to find these header files. So let's type that path in. Hit Control S again, and we're compiled. I'm going to drag this extern in there as well. I'll copy and paste it. Hit Control S to save it all. Okay, let's start by creating some threads. I want to make some things a little clearer for me. I'm going to create a init task call. This will start up all our tasks. Let's copy this function and we'll stick it here. So when our application starts, it will call init tasks. OS time delay is a delay thread. A value of 20 is equal to 1 second. You can also define it as ticks per second. If you click on it and hit F3, it will take you to constants.h file, where you can see where it was defined at. Okay, let's create our thread files. We're going to create a new source file. We're going to name this task1.cpp. And we're going to do the same for task 2 and task 3. You do not have to create individual files for your threads. You can do them all in the main application. I like to separate things. I like every file to have its own function and do its own thing. That way if there's a problem later on the road, I know exactly what file deals with that and jump right to it. Now let's create the header files for the 3 task files we just created. You don't need to do this. You can create their external objects in the main header file, but as programs get more evolved and larger, it's easier to keep things better organized. Alright, we have the 3 header files, the 3 task files created. I already wrote this application out, so I'm just going to copy and paste it in here. This is task 3. It's just an incrementer counter. It'll increment count 3 every second. We'll do the same for task 2. The only difference is we're using a different counter, count 2, and every half second. We'll do the same for task 1, a different counter. This one will display the 3 different counters and will be delayed every 50 milliseconds, or 1/20th of a second. Now I'm going to place their functions in their header files so the main application knows where they're at. I'm purposely leaving off the semicolon here. The star or asterisk in front of the file name means that file is not saved yet. You can hit Control S to save it, or Control Alt S to save them all. These red indicators mean there's an error. You can hover over the red X circle and it'll tell you what the error is. We've not defined a variable called count, so let's do that now. I'm going to define counts 1, 2, and 3 as variables. We need to make these to global, so we'll do this in the header file. And now I hit Control Save and it compiles. We still have yet to initialize the tasks. But first I want to initialize all the variables to 0. Okay. Control S, saved, it compiled. Let's create the threads now. There are several different ways to create threads. I'm going to show you the most simplest one to use. First, we need to define their priorities. This is all well documented in Netburner's documents on the priority levels. I'm going to start thread task 1 with the lowest priority. And I'm going to make threads 2 and 3 higher priorities, or I should say lower priorities. This one here we will use for the main task. And I'm going to set it for the lowest priority. I probably should add a comment in here so it makes more sense of where I got these numbers from. These are also in the documentation. This OS change priority for the main priority task, this while loop, anything below this, or I shouldn't say anything in the main loop this is where main priority is defined right here. It's set at a value of 50. I do not want to use that. I want to make it an even lower priority. Most of my applications do nothing in the user main application. They're all done in the threads. Let me copy and paste that and include here so it makes more sense. This is from their documentation. It explains what threads can, what priorities can or cannot be used. So 46 is the highest priority, which means it runs the fastest, and 62 is the lowest. Since I don't do things in main, I always make that the lowest priority. You can hover your mouse over the words in different parts of the code and it will show you what they're defined at or what they're about. It's a very handy feature. So let's start by creating the initialization for the tasks. Well, a simple task is what it is. It's the simplest way to create a task or a thread. The first parameter is the function call, name that we've named it. The second parameter is its priority, and the third parameter is typically used for debugging. So when your application is running, it will show up task 1 is running, task 2, or whatever you decided to name it. You click on F3, it will take you to ucos.h, where you can see other methods for creating a task. OS task create is very powerful. This can be used if you need to change the stack size. If that particular task you're using needs more RAM available to it than the default, that's the one you'd want to use for that to increase its task size versus changing them all. So let's change all these to task 1, 2, and 3. I have an error. Task 1 was not declared in scope. It's probably a typo. I've named it task underscore 1. I did not include the externals. Okay, so let's include them. We're going to bring in the task 1, 2, and 3 H files. Okay, another error. See, that's where I left the semicolon off. It's a very handy tool for grabbing errors for you real simply, showing you what the problems are. Okay, that compiles. I still have an error here. Task underscore 1. Okay, typo. I use caps. Alright, let's Control S to save it. Now we got to compile. Let's get rid of these. And we're ready to release this program. When the application starts, it's going to run init tasks. You can also hover your mouse over it and it will give you a little clip of that function that's there, or you can hit F3 and it'll jump you right to it. I'm going to open up the serial application. Oh, it's on COM3. I got to connect it. Hang on a second. Alright, let's try it again. There we go. COM3. Connect. Now this application is already running on the board. That's why you see the numbers already at a higher value than 0. Let's download the application to it via Ethernet. Since we've not done it before, we need to set it up. Double-click Netburner Launcher. It'll open up this application. Click Apply, and it just downloaded it. We're going to wait for it to reboot. there it's rebooted and we started our counters. Since the tasks are running at different rates, this is why the numbers are counting at different rates. They're all running independently of one another, and task 1 is the one responsible for displaying it. Let's take it out of there and put that in main, so all 3 tasks are just increment counters. Now take note that this main thread is running at 1 second, so it's not going to update the counts as fast as you saw before. Let's hit Control S to save this. We've got a good compile, which is shown down here. Let's run it. And now you'll see it's updating every second. The numbers are incrementing at their same typical rates. It's just with that main thread running at a second, we're only updating it every second. Main priority is running at a task 62, which is the longest. So that wraps up this video. Again, everything here does not have to be the way I've done it. It's just a way I do it, and just giving you a leg up on how easy it is to develop for this package. Thanks for watching.